Hello student, welcome to chapter 2 of the course. We will now be talking about organizing data visually, and there are several reasons for doing that. One, it is through the distribution or shape generated by the data. We will learn more about the distribution shortly, but it is important to know the distribution so we can analyze and interpret the data on the basis of estimating the population just from this particular data alone. As mentioned in previous video, there are two types of data, qualitative and quantitative. This video will explore how we summarize qualitative data. For qualitative data, we commonly use a list of the following visual graph: pie chart, bar graph, Pareto chart, side-by-side bar graph, and stack bar graph. This is not a comprehensive list, but some common one, and we will not be doing all in this video. It is recommended that you read and take note of the kind being used in this textbook. In order to talk about some of these visual graphs, it is important to define what is frequency distribution and some closely related types of distribution. Frequency distribution is a table that summarizes data on the basis of category and tallying the occurrence of each category. We call that frequency. There are several ways to organize frequency distribution. The basis of just category and frequency, that is called frequency distribution. And then we have something called relative frequency distribution. Relative frequency distribution and cumulative frequency distribution. Okay. And they are distribution. Distribution are organized in table. Then we translate to graph for better visual. The graph of qualitative frequency distribution is called bar graph. Bar graph. The graph of cumulative frequency distribution is called ogive. Other kind of graph similar to bar graph is called frequency polygon, where instead of using bar, we use point. And then there are many more. Okay, let's absorb all these terminology with some example. In this example, we have data collected from statistics students and their major. For simplicity, we will just limit to 5 different majors. We have English, math, biology, business, and liberal arts. To construct a frequency distribution, the first step in looking at the data is to determine the number of category or class, as the textbook would call it. Please note we also use frequency distribution in quantitative data, as the textbook covers it extensively. However, with the current technology, the process for constructing quantitative frequency distribution can be simplified. I encourage you to try constructing some quantitative distribution problem from the textbook to get a bigger picture of how classes and other important characteristics of frequency distribution are determined. For this lesson, we will look at qualitative frequency distribution. So back to this example. Since we have 5 majors, we will have 5 classes. So making a 2-column table like this one here, with major label in the first column and frequency in the second column. And we can determine how many of each class appear in the data. For qualitative, it's as simple as that. For quantitative, not so much. It is very specific in detail. Once we have the frequency distribution, it is easy to construct relative frequency distribution or relative distribution. In the same manner, there are 2 columns. So you see here. with the same labeling as frequency distribution seen above. But instead of telling it with number, that you notice above, we have decimal or percentage. So you see here, for English, we have the frequency of 10, and there is a total of 48 in the data. So we take 10 divide 48, that gives us 0.208. So we do the same for the other 4 classes, and we have this table to represent relative frequency distribution. Now, going back here, we have frequency distribution table. We translate the frequency distribution table with a visual we call bar graph. So from this table right here, we have a visual that you see down here, and we call that bar graph. Notice that this bar graph is simply a graph that has a horizontal and vertical axis to represent measure and frequency. And the bar here determines how many there are, the frequency. This graph here is called frequency polygon. So what does the frequency polygon look like? You can see here it is not bar. Instead, it's plotted at point, and we connect the dot with line. So instead of with bar that you see in the bar graph here, you will see point to represent the frequency, and then you connect the point with line. A special kind of frequency polygon is an ogive. A table that summarizes ogive is cumulative frequency distribution. We do not have it on this note. So you see in this example, we begin with English. This example from the relative frequency distribution here. We have English at 0.208. And we're going to add that with math, which is 0.083. And that gives you 0.291. And you can see from the ogive here, we plot English at the 0.208, and for the math, we don't plot it at 0.083, but we plot it at pretty close to 0.3, because when you add English with math, you get a total of 0.291. So we plot math near the 0.3 mark, right here. And if we add 0.125 for biology, then for biology the total is 0.416, and we plot biology a little bit close over 0.4, and so on. 2 other graphs worth mentioning is the Pareto chart, which is the same as histogram. The only difference for Pareto chart is it is order from graded to least or least to graded. So you see in this example, business had the graded number of students, and math had the least number of students who major. So we order business first, and then go all the way down to math. Or you can do vice versa. You can start with math being the lowest, and then start increasing, making it business being the last. And the last graph to show is the pie chart, which is simply a whole 48 students divided into small parts, which we call classes, proportionally. As you see here, the percentage of circle for each major, and the color legend here that represent the class. We will explore summarizing quantitative data in the next video. So see you then.